finally we get to what we call a controlled experiment. In a controlled experiment, your researchers take control and they assign the subjects to the control or the treatment group. And this ensures that the two groups are nearly alike in every relevant way except for the treatment that you're investigating. And I think the word that I left out here, the really, really important word, is randomly. A well-designed and executed controlled experiment is the only way to determine causality. A well-designed controlled experiment will have 4 key features. It must have that random assignment. It must have that. And then if we want it to be a really good controlled experiment, it will have these other features too. It will have a large sample size, a placebo, and it will be double-blind. These two aren't always possible, but if they are, we would like them to be there. Okay, so your random assignment is assignment into your control and treatment group being left to chance. No human would determine the assignment. You would flip a coin, you would use a computer or a calculator to randomly assign. Human beings are biased in nature, and so you want to take yourself out of the situation and leave it completely to chance. Bias is when the results of your study are influenced in one direction or the other, and it happens a lot if you do not use random assignment. Okay, double blind. That's when neither the researchers nor the participants know who is in the control group and who is in the treatment group. We want this because it prevents bias from group members who may act differently if they know that they're being treated a certain way. And it also prevents bias from the researchers who may evaluate the subjects differently based on what they know, what they hope, or they expect to happen. Okay, we want to decide whether each of these is an observational study or a controlled experiment, and also explain why. Okay, we've got to study the effect of smoking on lung capacity in women. You find 100 women, age 30. 50 have been smoking a pack a day for 10 years. The other 50 have been smoke-free for 10 years. You measure the lung capacity of each woman. Okay, what you're looking for when you're looking for the difference between these two, observational study or controlled experiment, is you're looking for random assignment. So I do not see random assignment happening here. I actually see self-selection. These women self-selected whether they were going to be smokers or not. They made that choice. So this is definitely an observational study because of that self-selection. In order to determine whether a new chemotherapy drug A has a greater effect than the current standard treatment B, you randomly assign, so I see the keywords here, patients to be treated by one or the other of the two drugs, and you compare the response rates. So because of this random assignment into groups, this is definitely a controlled experiment. A group of children is randomly divided into 2 groups. I see it again, randomly divided. One group drinks a colorful sugary drink, the other drinks water. The behavior of the children is recorded for several hours afterwards. So this is definitely, again, a controlled experiment because I see that random assignment into groups. Now, follow-up question to that is, assume that the researcher knows which children are in which group. How might that affect the conclusions that are drawn? So the researcher knows exactly what children drank the sugar drink and what ones drank water. And how might that let bias enter into their conclusions? What I see there is I think they might evaluate the children differently. They might evaluate their behaviors differently. They may expect one group to be more hyper than the other. So they might observe two children acting basically the same way, but because they expect the one who has drank the sugary drink to act that way, they might evaluate their actions differently. They might chalk the other child's behavior up to just being a typical 3-year-old. A group of overweight people are asked to participate in a weight loss program. The participants are allowed to choose whether they want to go on a vegetarian diet or follow a traditional low-calorie diet that would include some meat. Half of the people choose the vegetarian diet and half choose the control group, and they continue to eat meat. Suppose there is greater weight loss in the vegetarian group. Okay, I've saw all over the place up here keywords that let me know this is an observational study. There was self-selection. They were choosing which group they wanted to be in. And so because of that, there's going to be compounding variables everywhere. So it says suggest a plausible compounding variable that would prevent you from concluding that the weight loss was due to the lack of meat in the diet. So an example here would be someone who's willing to change their diet drastically. They might also be changing their exercise, maybe, sleep habits, possibly other dieting supplements, etc. And any one of those things could actually be causing or affecting their weight loss. And that's just one quick example. There would be many more. What would a better way be to do this experiment? To remove the influence of compounding variables? Well, that would be the random assignment.